Yep, so we're going to be starting off with one weird analogy. We're then going to be going through evolution and how our practices change and how personalities develop within our organization. And then I'm going to give you some key best practices to take away from today's session to implement a great analytics culture in your own organization. So we'll start off with the weird analogy, the basic two-slice toaster, that design classic. Now, they just don't make them like this anymore. €5, 99 cents. But this miracle, this apex predator of student cuisine is actually so much more in terms of evolution. Let's talk about where the two-slice toaster came from. Behind this design giant is actually a global supply chain. We talk about a dynamic worldwide network where companies like Lidl or Tesco or Walmart purchase and use these goods and services from just about everywhere in the world. It involves people, it involves resources, it involves information crossing borders, all to deliver this culinary marvel to the customer. And I want to bestow another honorific to this particular toaster. I want to call it a commodity. Now, when I say commodity, there are certain characteristics that are often used to describe commodities. They might apply equally to a bar of gold or to our humble toaster. Now, first of all, the characteristic of ubiquity. This means that it's widespread in the market. Secondly, the characteristic of certainty. It's well understood. I think if we go and buy a two-slice toaster, we all know what we're getting. Now, when you read articles in the press and in journals about commodities, you often find that they're focused on use. And possibly commodities even become invisible components in a wider process. Think about electricity as a form of power. You know, it's not magic. It's really slightly boring and slightly predictable, but it's an essential component of more advanced capabilities. And as we work to refine our understanding in the commodity space, we're looking to reduce the cost of deviation in the supply of our commodity. Let's move on. Let's contrast and talk about the product space. So products find that their characteristics of ubiquity and certainty are rapidly increasing. When we see articles about products, it's all about installation, maintenance, and operation. You drop onto websites like YouTube and you see people unboxing products, talking about their brand new features and why they're so much better than last year's model. Let's go further. We'll talk about custom components. Now on the screen here, I've done a screen grab from the website Kickstarter, and Kickstarter is all about rapidly learning more about a product space. So for example, on the right-hand side, do we really need a biomass stove for outdoor cooking? Well, if it gets funded, I guess we'll find out. In this space, ubiquity is really slowly increasing. It's kind of niche markets early on. And in this space, there might be a final solution for a customer need, and it might not look like anything that's currently being proposed, as you can see on the screen. In this space, we talk about reducing the cost of waste in a solution through learning what works and learning what doesn't work. And then finally, the domain of the crazy. There is almost no ubiquity and very, very little certainty. So components in this space might be a huge source of future wealth, but right now they require significant investment, even to understand how the product and the market fit together. So this space is all about experimentation. Now, this is very much an evolutionary process. In the diagram above, you can see that components tend to move from the left, the world of the crazy, to the right, the very well understood and the very widespread. Can we find examples of products that move the other way? Start on the right and move to the left. My example for you today is, can we custom build a commodity such as a toaster? Well, it turns out in 2009, an artist called Thomas Thwaites tried to actually achieve this. He wanted to really make an artistic commentary about our relationship with modern consumable products. So he mined his own iron ore. He got some Welsh rocks, he mined them, he extracted them, and he brought them home. He then smelted those rocks in his back garden. Please, please do not try this at home. You will not have any neighbors who will talk to you anymore. Or this, smelting in a bin. He even made his own plastic, and he plugged it in. Can anyone guess what happened? Well, I'll tell you something. It actually worked for 5 seconds, and then it exploded. The thing here is, you've got to realize he built a product that contained only 5 of the 100 components that exist in our basic 2-slice toaster. And Thwaites' message was actually quite interesting. The real cost of objects is hidden to us. Even the most basic universal toaster has all of these components that the end consumers never see. And I really want to use the analogy of this evolution from brand new, Genesis, through to custom building, through to products, and through to commodities or utilities, with the example of analytics. And I want to show you that we're actually going to go through exactly the same steps in our analytic process. So let's start off by looking at the analytic supply chain. Now, some of these steps are going to be very, very familiar to you. I've talked to some data scientists in the room today, and you've told me that you have teams that work on data cleansing, bringing data from a number of different sources, preparing and blending that data, enriching the data in a variety of ways. Maybe we geocode our customer address file, maybe we calculate drive times, maybe we then apply more advanced predictive or prescriptive analytics before getting it into production and delivering it to our end users. Notice all of the touch points. Notice how many points in this supply chain things can fall off the truck, get lost, or need to be rebuilt. It would be so much easier if you had a platform stack that allowed you to generate business-changing outcomes without all of these patchwork processes. Now, something at Alteryx that we talk about a lot is using Alteryx as a verb. You already Google for search. Let's talk about Alteryxing for insight. And on the screen are some of the other verbs that we talk about: discovery and collaboration from all of the sources that you use in the enterprise. We talk about data prep and blending, everything from local files through to those enterprise sources being brought together. Enriching the data, customer demographics, location intelligence, all in one place. And then analyzing and modeling your data, using the best of open source, using the best of pre-built and pre-configured tools. Finally, before deploying and managing that solution. Now, one cultural problem that we find at that intersection between custom-built and products is competing solutions syndrome. Now, some symptoms of this syndrome, where these two worlds bang up against each other, is the massive use of spreadsheets, the overuse of spreadsheets, the build-up of uncoordinated analytic groups, and the viral uptake of what I will call a shadow analytics culture. This is analytics without proper governance, analytics on grey data sources where we don't truly know the lineage and provenance of our data, and an over-reliance on descriptive analytics, of interactive visualizations. And it's not just spreadsheets that I'm talking about here. I actually read a tweet just the other day that quite surprised me, and it was all about what's been the most interesting thing and the most surprising thing you found in the analytics space over the last 5 years. The response was, Hadoop. We thought it would simplify our analytics landscape. It's actually made it more complex. Let me tell you a little bit more about waste in this area. We commissioned a study with IDC, and they uncovered some pretty uncomfortable truths. So for those advanced spreadsheet users among you, 12% of all enterprise employees, if I'm honest, spending up to 28 hours a week, if you can believe it, inside Microsoft Excel. But that's not all. They're spending 9 hours of those 28 hours every week simply reworking those spreadsheets as new data arrives. They're re-crunching and recalibrating those pivot tables. They're wasting 10,000 euros each, the equivalent of 2 billion hours in Europe alone. So just like the toaster from Thomas Thwaites, we're wasting time building custom-built components that are already products or already automated commodities. Now, I'm going to throw a couple of examples up on the screen. These are from our customers. They've been published on our website, but take a look at their problems. I'm not going to go through it in detail, but it's labor-intensive processes, trapped in VLOOKUP hell, manual intervention across that analytics supply chain, and trouble with scaling analytic processes to be truly global. And what happens after you deploy a modern analytics platform? There are some consistent words up here on the screen. It's repeatable, it's consistent, it's giving you predictable outcomes through automation, and it's also sharing and collaborating, bridging the gap between your users that have business domain expertise and your experts working in languages like R and Python, and building out data science models, evolving into a mature analytic outcome. Now, in our platform, we see evolution handled differently by different parts of the platform. Over in the Wild West, on the left-hand side, we talk about operating in a code-friendly way, taking the very best of breed from open source. This might be the latest R or Python library. This might be a new Jupyter notebook that's been provided and hosted by GitHub. All of those things come into play with the platform. Next, when it comes to being custom-built, we take these components and we build reusable data pipelines. We call these workflows. As we move more into a product or a service, we talk about delivering analytic apps to users that don't want to engage with a technical solution. Simply access your analytic insight through a browser. Simply have it scheduled to deliver that insight on a repeatable basis. And then finally, as we move to the commodity or the utility side, it's about packaging up this content as analytic services to be reused. Now, we also see an evolution in the staffing of analytics, and I'm sure many of you in the room will understand this approach. Now, the evolution of people in the process directly affects how the platform is used. So we've done some research, and we looked at the skills gap within data science today. So over on the left-hand side, we have a bunch of users with that business domain expertise. We have a bunch of data scientists. Now, in the world today, we roughly see around 1 million data scientists. The research we ran scaled up from the US, and we found around 1 million when we take into account all of these different job roles. In the middle are a class of users that are really brute forcing their analytic work inside spreadsheets, inside VLOOKUPs and macros, but also writing SQL, non-maintainable SQL, directly against data sources. Now, we call these citizen data scientists as they emerge over the next couple of years. They are going to demand the ability to access data and analytic resources without the need to code. This is a crucial gap in the current process today, and it's something that we're passionate about as part of our platform in enabling for a more successful analytic culture. Now, we've also identified 3 different cultural, let's call them attitudes, that apply at different stages of that evolutionary process. And this is a kind of concept that we apply after we've understood our analytic landscape, after we've understood our customer needs, and after we've built out structures of work to deliver those. Now, this might be everything from a 2-pizza data science team all the way through to the delivery of an analytic service. And the cultures in each of these attitudes are actually very different. So, for example, in the uncharted space, we're dealing with the unknown, the rare, the poorly understood. Here, we're going to be talking about pioneers. Pioneers are brilliant people. They show us some wonder, but they do fall over quite a lot. Now, half the time, the things that they build doesn't work properly. They create crazy ideas, and in a previous life, maybe they were burnt at the stake as witches. We're not quite sure. But this type of innovation might be called core research in many companies. Next, we move on to the middle space, custom building and products. We call these settlers. Settlers are also brilliant people. They can turn a half-baked prototype into something that's usable for a much larger audience. They make the future actually possible, and they make it happen. And then finally, to the right-hand side, we have what I'm going to call town planners. Town planners are also brilliant. They can take those products that your settlers have built, and they can deliver it to scale, deliver it on a global basis. Now, to stimulate this evolution inside your organization, you need to have what's called a system of theft. Basically, the pioneers invent stuff, the settlers steal from them. What's working gets turned into that basic product. The town planners then steal from the settlers and scale it up. And at that point, what the town planners have built, be it an analytic API, be it a service, be it a platform, in turn gets stolen back by the pioneers to address a higher value analytic need. And the system progresses, and we evolve with the content that we produce and hopefully build better products. Now, in terms of this system of theft with analytics, to the left-hand side, we have our data scientists building with the very latest code. In the center, we have our analysts, maybe building workflows using existing platforms, maybe consuming through a web-based gallery interface. And to the right-hand side, Those town planners, well, they're the analytics community, the teams that you build up internally and leverage external relationships to build new content across an entire global platform, which your data scientists can then reuse for that next level of value. So, analytics culture is a data-driven culture. It's an experimental culture. And in cultures where we run more experiments, we get better feedback, we learn faster. I just want to give you a quote from Jeff Bezos, the CEO of Amazon, where he says, "It's not an experiment if we know it's going to work." So think about that fact that we need to fail, we need to learn what doesn't work as much as what does work. Now, over the past 6 months, I've been working on lots of definitions of analytic culture. I've probably got a digital wastebasket that's overflowing. I've tried people, processes, and technology. I've tried those Wardley maps, which I'll talk about more in a moment, showing that evolution through different components. What I've settled on today is the dictionary definition of culture. And there's a lot to read on the screen, so I think I've simplified the key words. We need to improve those things at the top, to change the things in the middle, all the while managing the items at the bottom of the screen. Now, culturally, this is actually quite difficult, and we haven't even got to the analytics yet. Some research from Krinsky and Hetrick really resonated with me, and this is where we take customers on a journey. We tend to find on the left-hand side these older, more toxic practices around a culture. We find individuals working rogue, working in the dark after hours, typically working in tools like Excel, but not limited to Excel, maybe working in RStudio on a desktop. All of these things cause problems for an analytic culture. We try and move to the new and emerging practice on the right-hand side. It's more transparent, it's more open, and it's more inclusive of talent across divisions and across backgrounds. So, to finish off my talk today, my last 5 minutes, I've identified 7 cultural practices that'll help you bridge that gap between your analysts, your data science groups, and your technology groups who have to keep everything running smoothly. So first of all, practice number 1, data access. We need to make sure that a strong analytic culture enables the following 3 things: discovery, organization, and collaboration. Over on the left-hand side, I bet no one in this room could honestly say all of their data was in one place. I don't care if you have a data lake, I don't believe you. Instead, you will have data warehouses. You may have a data lake. You may have web applications like Salesforce that hold critical information. And you will have hundreds, if not thousands, if not millions, of spreadsheets and local files, hopefully not on one machine, but spread across network drives and other locations. With a social data catalog, you can bring all of this together as metadata. We can understand the lineage of how data flows from a data source through a data pipeline, maybe into a consumption layer like Tableau, Power BI, or Qlik. We can understand who owns, who champions, and who governs this information. But crucially, we can take the tribal knowledge, the silent knowledge of all of your analysts, your data scientists, and your leaders, and start to interact with these data sources and these definitions. The first mile of analytics is so important to get users working with the most trusted, the most reliable data sources. Secondly, we've seen the slide already, but analytic harmony, taking those fractured processes that we mentioned earlier on, all of those different touches in the analytic pipeline, and bringing them together in a self-service platform that enables one user to ask a question, to know where to go, to build something out without writing code, and then to deliver those insights without having to worry about how to stitch it together. Brings me on to my third practice, collaboration and reuse. We've already talked about the idea of collaboration between analysts and data scientists and technologists, but what happens when a user wants to incorporate some great new open source library in R or Python? How do we bring that in? How do we make that repeatable? We have to have a way for all of our users to have a voice. When I talk about reuse, let's talk about the anti-pattern. So we all think that reuse is generally a good idea. I produce a workflow, I can share it with somebody else in a very structured and governed way. But what happens when I don't reuse something? Well, I recreate it from scratch. And then we're back into the world of waste in the middle of the process. It's so depressing to see people reinventing the wheel, creating the same content over and over again. This brings me on to another anti-pattern that I often see. In data science, What does running in production actually mean? I've already had some great conversations with some of you today about this. Does this mean I can run a model on a machine? Does this mean I'm stitching together 20 open source frameworks to get it running through a web service? Well, if you don't deploy it, it didn't happen. And this applies not only to data scientists, but also to analysts and also to end consumers. I want to be able to take a workflow and make it available self-service to a much wider audience, hundreds of users, thousands of users. I want to be able to take my data science model that I've coded in R or Python and embed it inside a product or a service. Very briefly, look at the data science pipeline. To the left-hand side, we have data scientists building their models and testing their models. And again, they jump through these hoops just to get the model live. Maybe it goes to IT. Maybe IT don't work in R or Python, and they have to recode in Java or .NET or C++. Then it hands over to DevOps to get this into a continuous integration mode. All of this happens before a customer can actually touch it and gain the benefit. Very, very briefly, only 13% of data science models get deployed at a cost, on average, of $250,000. 6 to 9 months to get that cycle end to end. This is an enormous source of waste, and it's a huge anti-pattern. Let's move on to analytic skills. I'll just build this slide up. So a couple of my friends, Kim Nilsson and Phil Harvey at Microsoft, recently gave this talk and this slide at Strata. They talk about personality types. They talk about actions that we can take with analytics, and they talk about analytic outcomes. And they're broadly classified as either soft or hard. I can be empathic and have compassion about my personality, or I can be results-driven and only consider hard skills. The trouble is, on the left-hand side, we run too much of an intuition, a gut feel approach. We might get the right answer, but it's not repeatable. Over on the right-hand side, it's just not sustainable unless you come from Google, Netflix, Apple, or Amazon. So we need to find a balance in the middle, the balance of empathy, the balance of being results and data-driven, but by using a blend of code-free and code-friendly tools to deliver customer engagement and also repeatable profits. I want to talk to you briefly about enablement inside your own organization. I want you to think about opening your doors to a concept called office hours. Maybe once or twice a week for 1 hour, your door is open. If somebody has a data science problem, if somebody has trouble understanding what a definition means in that last talk, what does churn mean across your organization? Championing techniques like office hours starts to enable much wider communities and bridges that gap. Coaching is a natural extension of office hours, and certification in any number of different tools or platforms is a logical next step from this point. When you're ready, champions start to emerge from across your organization, and I want you to venerate and award those champions with all of the epithets you possibly can. They are taking your insight and your analytic knowledge forward. Now, I come from a platform vendor, and I don't really want to talk about them on stage right now, but I do want to say, if you choose tools, there are 4 major criteria that will help you enable a better analytics culture. I want you to consider how they work, how powerful they are, not only in functional capability, but also in performance. I want you to choose tools that are easy to learn. That is, when you're demonstrating to one of your colleagues, they steal the mouse off you in the middle of the demo and start trying things for themselves. I want you to choose tools that support teamwork. Collaboration in data science is absolutely critical to make this more of a success. And then finally, the tools that you choose, the best tools, will be loved by their communities. So I'm very proud to mention this slide that we are a gold winner when it comes to Gartner's Peer Insights. This is not an analyst review, this is feedback from customers to say that they couldn't do their jobs, they couldn't produce these repeatable, scalable analytics without my platform. Now, I'll finish up by saying if you'd like to learn more, there's a great TED talk on that toaster that exploded, and I'd also recommend you have a look at Simon Wardley's website, where he talks about strategy mapping and the evolution of components in more detail. But with that, I'll say thank you very much, and I'll take any questions.